Okay, so last video we worked out the solution to this where we convert 4 plus 7i to polar form, and what we got was that the complex number z is equal to square root of 65 cos 60.26 plus I square root of 65 sine 60.26. So we're going to move to the next problem, but let's just erase these things and then we go to it. Alright, so we erase, let's erase these parts of the board. Alright, so here now, we have this to erase 2. We're asked to convert 4 open bracket cos 2.5 plus I sine 1.3 close bracket to rectangular form, and the 2.5 and 1.3 are in radians. Now, before we do anything, remember the radians and degrees. If you have a circle, you have the center, and this is a radius, this is another radius, and the length are right along the arc from here to here. That's the arc length, goes right along here. If this is a radius r and this is a radius r and this length is a radius r, then the angle here is 1 radian. So theta equal 1. It's radian, but I just put 1 rad for it. Alright? How many radians do we have? Just a reminder of the trigonometry involving radians and degrees. That's what we're doing quickly. How many radians do we have in a complete revolution? Well, if we make one complete revolution, what would be the arc length? The arc length would be what we call the circumference. And remember that circumference is equal to, remember the formula, pi d, which is the same as 2 pi r. So since the r, 1 r is a radian, okay, and just call this rad. So 1 complete rev is 360 degrees, so 360 degrees is equal to 2 pi radians. Alright? Now, here, when we're going to deal with this, and I don't think we're going to need the answers up here. Alright, when we're going to deal with this, we have to put our calculator in radian mode. Now, let's first of all, well, if you want, you could multiply out the bracket, remove the brackets. Right? It might feel a little more comfortable working it that way. So you have 4 cos 2.5. This is what? Question 4. So question 4. For question 4, you have 4 cos 2.5 plus 4i sine 1.3. 4i sine 1.3. I could have written it as I4 sine 1.3 as well, right? It's just that it sounds a bit more comfortable to me saying 4i than I4, right? Now, what we have here now are in radians. So what is z? We're going to calculate z. This is going to be the real part plus the imaginary part. So let's see what 4 cos 2.5 is. Now the thing is, if you're not sure about your calculator, you could do a little test on the calculator before you proceed. Now, for example, oh my, why jump up there? For example, suppose you consider an angle of, say, 30 degrees. 30 degrees is how many radians? Well, we know 360 degrees is 2 pi radians. If you divide both sides by 360, you get 1 degree is equal to 2 pi over 360 radians. And then 1 converted to 30, you have 30 degrees is equal to 2 pi 30 over 360 radians. So here now, cancel down, 2 into 2, 1, 2 into 360, 180. Cancel the zeros, 3 into 3, 1, 3 into 18, 3, 18, 6. So it's pi over 6. So it's pi over 6. So 30 degrees is equal to pi over 6 radian. Now, the calculator, when you put it in degree mode, you find, say, sine 30. When you put it in radian mode and put pi over 6, you should get the same thing. So let's see something here. Let me widen my calculator to show all the functions. It's covering up the screen, man. Let me see if I can get it a bit narrower. Bit narrower. Alright, so, oh no, wider. Yeah, alright, we see them now. Just want everything there. So, degrees, 30. What is the sine of 30 degrees? We have 0.5, okay. Now, let's put in radian mode. Degrees, angle in radian. Now, what is the sine of open bracket pi over 6? Do I have a full pi here? I should have a full pi. Alright, pi divided by 6 close bracket equal. So, pi over 6 radian mode. Oh, it should be, let me see something here. The angle is in degree. Degrees. Suppose I find, alright, this is radian. Where is it? Is it degree here? Let me try this thing. Just to make sure, because I haven't done much radian calculation with this calculator, so I want to test it. Sine 30 equal 0.5, it's in degree mode. If I put it in radian and find sine 30 again, 0.5, so how I put it, this one in radian, this one is in radian, and I say sine 30 radians, you say 0.5. Now 0.5 radian equal 0.5 radian. This is converting to radians, but I might have to use a different calculator than this, because it's not giving me the things that I was looking forward to in terms of radian and degree mode. So let's see this one. If I find the sine of 30, and this is in degree, equal 30. Oh, this is 30 sine. I have to press the number first, and I get that. Then clear and find sine. Oh, it's pi over 6. So open bracket. Where is pi? I'm not seeing a pi here. So I say 3.142 divided by 6, close bracket. 3.142 over 6 equal, right, that's pi over 6. And I say sine, good, different thing, because it's in degree mode. But if I put it in radian mode and say 3.142 over 6 equal, and then sine, I get a 0.5. So it is working here, right? This calculator, I don't trust it. I trust this one more. So if you have a calculator that you're not familiar with, whether you borrow it or recently bought it, make sure if you're going to do any trick involving degree and also radians, make sure you test it to see that it does work, right? That it is working. Now, what we're going to do is say 4 cos 2.5. Now that I trust this other calculator, I'm going to use it. So this is calc. That's the calculator we have here, right? And I say 4 multiplied by 2.5 cos. That's radian. 2.5 cos equal. So I have negative 3.2. So I have Z is equal to negative 3.2. So is negative 3.2 plus I. Then I want the sine. I'm going to use the sine now. So let's get back that calculator, and I say we have sine. Let's clear it. Sine. I said 1.3 sine, and then multiplied by 4 equal 3.85. So it is 3.85 or 3.85 I. I prefer to say 3.85 I. All right. So let's quickly review it. What we have is the complex number in polar form to write in rectangular form, but the angles are in are in radians, not degrees. Now make sure you know how to change the mode of your calculator from radians to degrees, and when you change it, make sure you test an angle. If you say sine 30, you get an answer. When you change it to radian and say sine 30 again, it should be a different answer, right? So you can find the cosine of say 360, and then in degree mode you should get I believe the cosine of 360 is 1. When you say cosine of 360, after you turn it to radian mode, you should not get back that, right? So what you do is say the You put the calculator in radian mode, say cos 2.5, then what you get, you multiply by 4, plus I times, then sine 1.3, and what you get, you multiply by 4. Alright? So, that's what we have. In terms of my calculator here, giving me some difficulties, I'm just going to look back at one or two things with this calculator, which I like it, you know, but oh, hold on. When I put sine 30, this is in radian, it's saying 0.5. It shouldn't be. But this is a problem I'm having with it now. Right? It's in advanced mode. I'm sure this is in radian mode. But anytime I'm going to do any calculation involving radian and degrees, I'll just use the other calculator. But anyway, this is your answer for that. Z equal negative 3.2 plus 3.85 I.